In today's video lecture, we are going to study about laser. Laser is a very important invention in the field of engineering and science with a number of applications. A laser beam is an intense and bright light which is different from the ordinary light. आता लेझर म्हटलं की डोळ्यासमोर एक आकर्षक आणि रंगीत लाईट बीम उभी राहते. फॉर एक्झाम्पल अशी और लाईक दिस. आता लहानपणीचं एक सेलवर चालणारं हे खेळणं तुम्हाला आठवत असेल. खेळण्यातले बटन प्रेस केले की त्याच्या अपर्चरमधून एक ब्राईट रेड नॅरो बीम डिस्प्ले होते, ज्याला आपण लेझर बीम असे म्हणतो. तर ह्या व्हिडिओ लेक्चरमध्ये आपण लेझरचा अभ्यास करणार आहोत. In this topic laser, the points we are going to cover are introduction to laser, properties of laser, stimulated absorption, spontaneous and stimulated emission, population inversion and optical pumping, and applications of laser. Now, the principle of laser is explained on the basis of quantum theory of light, or it is based on Planck's hypothesis. So before we start with the laser, let's try to understand the Planck's hypothesis. According to Planck's hypothesis, electromagnetic radiation, or we may say light radiation, is not absorbed or emitted in a continuous manner, but in a discrete or quantized manner in the form of bundles of energy, or we may say packets of energy, and these energy packets are called as photons. So now you have to imagine light to consist of packets of energy, and these energy packets are called as photons. Now the energy of each photon is proportional to the frequency of the radiation. So we can show this energy E of the photon is equal to h nu, where h is Planck's constant and nu is the frequency of radiation. So now, to begin with laser, let's see the definition of laser. A laser is a device that emits light through a process of optical amplification. Now laser, this word is a short form for the process by which this laser beam is produced. Laser stands for light amplification by stimulated emission of radiation. So we can say that this laser beam is amplified light, and this amplification is brought about by stimulated emission. So remember this full form. Laser stands for, laser is light amplification by stimulated emission of radiation. Now this light has got some special characteristics or special properties which makes this light different from ordinary light. So we will see the properties of this laser. First property of laser is that laser beam is monochromatic. So what do you mean by monochromatic? Mono stands for single and chroma stands for color. So when we say monochromatic light, it is a light of single color, and when we say it is a light of single color, it means it is a light of single wavelength. So light of single color and single wavelength. In comparison, the ordinary light such as sunlight or light from a lamp is a combination of a number of colors and hence a number of wavelengths. Now see figure 1. It shows light from different sources, and so it consists of different colors, a blue, a red, a green, and hence different wavelengths. So it is an ordinary light which consists of a number of waves of different wavelengths. But figure 2 and 3 show light of the same color, means it is monochromatic light and of same wavelength. Second property of laser is that the laser light is coherent. It means the laser light waves are in phase. That is, light waves are in the same state of motion at any instant of time. In comparison with ordinary light being a combination of waves of different wavelengths, they cannot be in phase. So ordinary light is non-coherent light. Now see the figure. In figure 2 and 3, the light is monochromatic of the same color, same wavelength, but in figure 2, there is a difference in phase, and so the light is monochromatic but not coherent. In figure 3, the light is monochromatic and also coherent as the waves are in phase. The third property of laser is that the laser beam is unidirectional. It is well collimated and travels a long distance with less diversion. The laser beam is narrow and focused at a point. Because of this, it can travel several kilometers with little divergence. The fourth property of laser is that the laser beam is bright and highly intense. As the laser beam is more focused at a point, it is highly intense and bright. In comparison, ordinary light is less focused and spreads over a large area, losing its intensity. After studying these properties of laser, let's compare the laser light with the ordinary light. So here you can see the points of differentiation between the laser light and the ordinary light. Firstly, the laser beam is monochromatic, and you can see in the figure it shows light of a single color, whereas the normal light is polychromatic. That is, it consists of a number of colors and hence a number of wavelengths. Second point is the laser beam is coherent. The waves are seen in phase, while ordinary light is non-coherent. It has got a number of waves of different wavelengths and hence not in phase. Third point, the laser light is collimated, or it is directed in one direction, whereas normal light is non-collimated, it is not directed in a single direction. Laser light is highly intense, whereas normal light has low intensity. Now let's try to understand how a laser beam is produced. We all know that matter is basically made up of atoms. The structure of an atom is shown in the figure. There is a centrally located nucleus made up of protons and neutrons, surrounded by different orbits or shells. Electrons revolve in these different orbits around the nucleus. The number of electrons in each orbit is decided by the formula 2n square, where n is the orbit number. The innermost orbit having the least number of electrons will be filled by 2 electrons. The next orbit, second orbit, will be filled by 8 electrons and so on. The energy of the orbit goes on increasing as we go away from the nucleus. In this situation, the atom is stable and is said to be in the ground state. If any electron is supplied with energy equal to the difference between the energies of the orbits, the electron absorbs this energy and jumps to the higher energy level, and the electron is said to be excited. In this state, the atom is also said to be in the excited state. The atom is unstable in the excited state, and after a very short interval of time, the electron returns to its original orbit, emitting the same amount of energy absorbed by it while making the transition to the higher energy level, and the atom is said to return to the ground state. We can show this with the help of an energy level diagram. Let's understand the concept with the help of this energy level diagram. All atoms before being excited will occupy the lower energy level with energy E1 and are said to be in the ground state. Now, figure shows a single atom in the ground state. External energy is provided in the form of photon of energy h nu, which is equal to the difference between the energy levels E1 and E2. So when the atom absorbs this photon energy, its energy is equal to E2, and the atom makes an upward transition to energy level E2. The atom is now said to be in the excited state. This process of exciting the atom to higher energy level by absorbing the stimulating incident photon is known as stimulated absorption. The atom is unstable in the excited state and returns to the ground state, emitting the absorbed energy in the form of photon. This is known as spontaneous emission. The spontaneous emission is more clear from this figure. The electron in the inner orbit, when it absorbs photon energy, it makes a transition to the outer orbit or orbit of higher energy. It remains there for a short time and then again makes a transition to the inner orbit. While making this transition to the inner orbit, it emits the photon energy which it had absorbed while making the transition from the inner energy level to the higher energy level or inner orbit to the outer orbit. Now, two very important definitions we are going to see: lifetime and metastable state. So what is lifetime? Now when the atom is excited, as I said, it remains there for a very short time and returns back to the ground state. The limited time for which an atom remains in the excited state is called as lifetime, and this lifetime is about 10 raised to minus 9 seconds. So it's a very short time. Now, sometimes the atom remains in the excited state for a relatively longer time than the lifetime. This is called as the metastable state. The metastable state plays an important role in the production of laser. It is about 10 raised to 5 times the lifetime. The metastable state is approximately 10 raised to minus 5 to 10 raised to minus 3 seconds. Now, let's see the second type of emission, the stimulated emission, the emission needed for the production of laser. Now, once the atom is in the excited state, before it spontaneously returns to the lower energy level, if it is triggered or stimulated by another similar photon of same amount of energy, then when the atom makes a downward transition, it emits two similar photons, one used for triggering or stimulating and the other energy absorbed for excitation. As both these photons are emitted simultaneously, they are in phase and so they are coherent. While energy of both the photons being the same, they are of same frequency and hence coherent. Thus, stimulated emission is monochromatic and coherent. Now, let's see the three activities: absorption, spontaneous emission and stimulated emission together. In this figure, you can see in the first figure, absorption, atom in the lower energy level absorbs photon energy h nu, which is the difference between the two energy levels, and makes a transition to the higher energy level. Now, once the atom is excited, there are two possible emissions. One is spontaneous emission, second is stimulated emission. The atom remains in the excited state for a very short time, that is lifetime, and it returns back to the ground level, emitting the amount of energy it had absorbed for excitation. So this is spontaneous emission. Now, when the atom is in the excited state and it is triggered or stimulated by a photon of energy h nu, which is again difference between the two energy levels, the atom is stimulated and returns to the ground state, emitting two photons. One photon used for stimulating and the second photon absorbed by the atom while making an upward transition. So here you can see two photons emitted in the third case, stimulated emission, which are in phase and of the same wavelength and same frequency. Thus, this emission is coherent and Now we are going to see two very important definitions or concepts necessary for the production of laser. One is population inversion. So population inversion is a state of achieving more number of atoms in the excited state as compared to the ground state. So in figure 1, maximum number of atoms are in the ground state E1. Now each of these atoms are provided photon energy equal to E2 minus E1 to make an upward transition. To produce a laser beam, it is necessary that maximum number of atoms are in the excited state. When maximum number of atoms are in the excited state, the system is said to be active and is ready to produce a laser. The state of achieving more number of atoms in the excited state as compared to the ground state is called as population inversion. If N1 is the population of the ground state and N2 is the population of the excited state, by population inversion, the condition which is achieved is N2 should be greater than N1. The population inversion is brought about by a process of raising or pumping the atoms from the lower energy level to the higher energy level using light. Once population inversion is achieved by optical pumping, the system is now ready for lasing action. Now, all the excited atoms are stimulated or triggered simultaneously so that all the atoms make a downward transition simultaneously. Every atom during its downward transition emits two photons, one absorbed during excitation and one used for stimulating. As the downward transition of all the atoms is simultaneous, the photons are emitted simultaneously and hence are in phase, thus coherent. Emitted photons are of the same energy and hence of the same wavelength and same color and hence monochromatic. This brings about amplification of the light by stimulated emission. The emitted light is hence a laser beam which appears like this. This laser beam with its special characteristics has a number of applications in different fields, which we shall see in our next video lecture. Thank you.